All right. Thank you very much. I'm very happy to get to present some of these ideas here. So we've been thinking about this stuff for a while, and we wanted to have a forum in which to talk about them, and this seemed like an appropriate place. I will tell you that, like, you know, maybe unlike other PARC forums you may have seen, which are more like TED Talk-like, this is just all work in progress. We're just working through a lot of these ideas. So there are going to be rough edges, and you know, you should feel, after I've kind of run through a bunch of the slides, there's going to be time for questions, and please ask me questions. You know, call me on stuff, pose difficult challenges, and all of that, because that's really why we're doing this, is so we can start to kind of I don't know, the corporate term is socialize the ideas. Perhaps the better term is like to air them out. So what I want to do is I think it's an interesting position that we find ourselves, the Innovation Services Group that I'm part of, which is that we are a design group in a basic research organization. So I'm going to talk a little bit about PARC in a minute, but the two things are historically not necessarily that, you don't necessarily think of design as part of basic research. Like, what is the role of design in basic research? And that's one of the things that we're trying to define, both in terms of what our group does, but also in a larger sense, because we think that there's real value to bringing design at the earliest stages of technology exploration. And we think that there's real value in bringing the methods of design, and that the design really brings an entirely different way of thinking about things that is valuable before you've even, like, you know, started making a thing bubble on the lab bench. But first, what I want to do is I want to talk a little bit about PARC. So, you know, this place has a very, very sizable history and a sizable reputation, and I wanted to kind of give a little bit of a taste of what that is, to put where we are today in context. So many of you know that, like, essentially PARC started in you know, just about 50 years ago as a captive research lab for Xerox, with the explicit, and I'll talk about this more later, notion of creating an office of the future. And in this, you know, and I kind of define PARC in kind of like the way they do comic books. There's like a golden era, and there's a silver era, and there's today. And so, which is not to say that today is any less fun, it's just a different universe. So in the golden era of PARC, we brought you the modern office ecosystem, which was essentially the laser printer, networking, object-oriented computing, WYSIWYG editing, things like PostScript came out of here, and object-oriented software, and also a whole lot of other material science research. Then there was the silver era, which, you know, kind of the 80s to the 2000s, which essentially where we created, you know, basically the modern mobile device ecosystem, where we created the first kind of networked computers that were designed not as a monolithic thing, but as part of a suite of things. So there would be like one thing that was a tablet, you know, the PARC Pad, which, you know, another thing that was named Pad after it. You know, that was in the late 80s, early 90s. Then there was a handheld thing that you could write on. There was a digital thing that was connected to that via network. That all seems very familiar today. And so then we get into kind of the current era. The current era, there's a couple of interesting things about it, and one of which is that we really broadened our lens of what it is that PARC can and should do. And so we work across an enormous range of hardware and software disciplines. And one of the things that makes PARC unique is that we can fuse those. So we work both on AI, So conversational interfaces, or essentially analysis of distributed sensor network data with like basic science, like novel sensors, novel printed sensors, novel technologies. So we can essentially bring those things together and create things that, that otherwise wouldn't cross those disciplinary boundaries. So, these are the things that I mentioned, the things that you use every day. One of the other interesting things about kind of the thing that's kind of run through all of this, through the entire history of PARC, is this like reconnection back to people, reconnection back to what people are interested in, how people behave, what they do, and why they do it. And that's always been part of the again, using business speak, the DNA of PARC. The other interesting thing I think and this is a 1970s photo, that I think is true about PARC is that it's always looked at the way that you create technology in a way that now feels very familiar and Silicon Valley-like, but has historically been quite different. It essentially takes an intentionally outsider's view on a lot of things in order to be able to create novelty and create a new perspective on that. There was, at the same time, going back to the 70s, at the same time that on the East Coast, they were looking at how can we have people use, how we can get more people using the same computer? How can we get essentially time sharing to be more efficient? How can we make even bigger computers? PARC's philosophy was like, no, let's not do that. Let's make small computers that everybody can have one of. And so that kind of intentionally outsider perspective has always kind of driven what it is that we do. So we currently have, these are roughly, I started to mention, these are roughly some of the kind of cross-disciplinary collaboration areas that we're focusing on these days. So, we're doing just different kinds of AI, but different kinds of AI that's kind of focused on in different directions. So, if you think about it, like the digital design and manufacturing, that's a kind of AI as applied to the way that things are created in 3D. So you look at a 3D file and you can do reasoning on it. You can reason on it in order to be able to, for example, find a new route between two places. But you can also reason on it to find a route for a machine that's cutting a thing out, or for something that is trying to find an organ when it's inside your body. So you kind of start to see different kinds of the way you apply AI in different ways. So it's not just essentially about chatbots kind of spitting back some funny stuff at you. So, and at the same time, we're doing things, and you'll see more of this later, we're looking at kind of novel manufacturing technologies. Like, how can you make electronics completely differently? How can you think about making things completely differently that are not in a conventional way? Currently, if you think about like the number of chip fabs in the world, it's like, I don't know, for the smallest ones, it's like 27. Think about the number of 3D printers in the world. What if every one of those 3D printers actually could print chips? You start to think about the same kind of democratization that you started to see with computers in the 70s. So we currently have, I don't know if this number, Greg, is this number current? Roughly, okay. So we punch way above our weight in terms of the number of people that are at PARC. We have about 140. Researchers with probably some like 40, 50 support staff, something like that. We file a whole bunch of patents all the time. We have spun off something like, or directly impacted some like 30 companies. And we are continuing to do that today. And today, I don't know if I have this in a slide, but you can see it right here. We don't just do it for Xerox. We haven't done it for Xerox for almost 20 years. Well, we have done it for Xerox, but not exclusively. We work for a large range of Fortune 100 companies, Fortune 500 companies, also startups, and also big international agencies. So you too can hire us to work for you and to innovate for you. Our group innovation services is, when I was saying that, we try to kind of encapsulate what it is that we do, a lot of what we do is we think about managing the risk of innovation so that you can take bigger risks. So a lot of innovation doesn't happen because people are afraid of failure. How can you reduce the risk of failure so that you can take bigger chances, so you can understand what those risks are? And we do that through a combination of kind of strategy and social science in terms of understanding how people work, and also user experience design, which I will talk clearly a lot more about. That's our group. You can look this up. I just grabbed this from the website. We come from a wide range of, we're not a very big group, but we come from a wide range of people. We have people from architecture, industrial design, social science, and software development, 2D, 3D, 4D development. But the goal is that when we bring people into our group, we bring them in primarily, or the thing that we're really interested in is their ability to work across disciplines, their ability to be able to just stand outside of the thing that they have done and pick up a new skill. So, speaking about design, I want to take this as an opportunity, because this is something that I've really been thinking about, to talk about, let's define design. Like, I know it's just a hobby for everybody who is in design, and I'll tell you what our perspective on it is. But I really want to talk about how we see design. If you look at UX design, so this is a diagram from Corey Stern, which I think is it's a great diagram. But if you look at this as a definition of UX design, you start to look around and it's like, holy crap, what's not in this? What does UX design not consist of? How is it different from customer experience design? Hint, it's not. How is it different from strategy? How is it different from, I don't know, the architecture of buildings? It's a challenging thing to define, and in fact, it's always been really hard. So I found this great quote the other day. So this is from Henry Dreyfuss, who's one of the founders of industrial design. This is from 1955. So one of the things I think is great is when he's saying, even today, the term leaves much to be desired. Design is not the exclusive property of the industrial designer. There are architects and advertising people and artists and dressmakers. And then and he's like, that's really hard to pin down exactly what's design. He's like, the term is one of the little agonies the profession must bear. So I think the fact of the matter is that the meaning has always been, of what is design, has always been almost intentionally ambiguous. And it's been essentially culturally defined by a lot of people who have self-interest in either aligning themselves with it or distancing themselves from it. And it's also shifted over time and geographically in the last half century for sure. For a long time, especially like in the UK, it was seen as essentially equivalent to engineering. Mechanical design was engineering. Structural design was engineering. Electronics engineering was design, which is why you still get magazines, especially in the UK, like International Design Engineer and from my perspective as a designer in Silicon Valley, like the ultrasonic welder that helps make toys is not really part of UX design from my perspective. Or, adding a linear seventh axis. Ooh, that's like for somebody in that space. But to me, that seems like an odd thing to be calling design. And especially here in Silicon Valley, design has somehow shifted to refer to only the visible aspects of our products, the interface, the appearance, like the brand. Just look at the front page of, like, this is today's subreddit on design. Like, what are they talking about? Let's look at this logo. Let's look at editing something in Photoshop. Let's animate this. Like, to me, somehow, a designer in this definition is somebody who's working on something that's just like on the surface. And if you want to work on anything that's not the surface, you call yourself something that's not design. Oh, I'm a front-end engineer. Oh, I'm a creative coder. Because somehow that's not design. Somehow that's not part of the design process. But if you look at what it is that we're trying to accomplish as both designers and historically as engineers, I think it's basically the same thing. So Herbert Simon, who some of you may have heard of, he won a Nobel Prize in economics, but he also talks a lot about design. So Herbert Simon wrote this in the late 60s. So he said, everyone designs who devises courses of action aimed at changing existing situations into preferred ones. He was explicitly talking about that mid-century definition of design that also encompasses engineering. But it also encompasses what we would call user experience design. It also encompasses what we would call architecture. And so John Chris Jones in 1970 was writing this, who, today if you look at the way that like UX design practice is done, like if you look at the way that IDEO works, or like they like to talk about their process, they kind of teach their process. If you read John Chris Jones's design methods book, it's 100% there. It's 100, and he was not working in an era of Adobe Illustrator and 3D printers. He was working in an era of vellum and drill presses. And so what he's saying is, what a designer does is a designer works backwards in time from an assumed effect on the world to the beginning of a chain of events that will bring that effect around. So that is what a designer does. You can see in Margaret Mead's work, so this is Margaret Mead and Gregory Bateson, talking about how design, Margaret Mead, one of the founders of social science along with Gregory Bateson, but also Norbert Wiener, the founder of cybernetics, who was a mathematician. They're talking about looking at feedback loops as a core aspect of what it is to create a new thing in the world. And that is the thing that Herbert Simon is talking about. That's the thing that John Chris Jones is talking about. They are looking at going forward into the future and then working backwards to create a loop that will then help you create that thing into the future. And that is the core thing that a designer does. I would like to say that this puts it at an interesting counterpoint to science, to traditional science as first defined by Francis Bacon in the 1620s. So the goal of the scientific method is to define, and this is incredibly powerful, is to define questions as clearly as possible so you can find empirical evidence that can be gathered to identify universal truths as they exist today. Science essentially is looking at the world as it is right now and trying to describe it and trying to understand what it is and how it works. This means that most scientific practice and the way that most people work in science and the way that they're rewarded in the scientific world in terms of the way they get published, the way they get promoted, the way they get bonuses at the end of the year, tends to favor descriptive precision. Scientists are rewarded for divining questions such that they can be unambiguously investigated and where the results are so clearly distinct from other results as possible. This leads to things that are deep but narrow, that go at universal truths, but they go at them with very, very clear distinctions about where that investigation goes and where it does not go. Design, on the other hand, has a different goal. Design's goal is synthetic. These are building the building blocks. Science is building the building blocks of the world. It is identifying and understanding the building blocks of the world. Design explicitly is looking at a possible future, a future cone of possibility, and cutting across all of the other disciplines to assemble them synthetically into a new future. So you can also see this in the way that designers are incentivized. They are incentivized, like if you look at the way the commercial designers are incentivized, they are incentivized by breaking the boundaries between silos, creating unique solutions that satisfy their customers and satisfy the end user. Those situations do not have to have those guardrails that science have. They only have to meet the needs of this desired future state. And that future state will change. Design is not looking at absolute truths. Design is not looking for absolute things that will be the case forever. It is using the building blocks that it has right now, and there are new building blocks that are created all the time by science, and it's trying to create a new future state, and the future state is moving all the time. But it is inherently a synthetic process. So, in other words, as we see it, science is what reads the world. Design is what writes the world. So how do we bring this into a research context? Well, design is doing an interesting thing when it's done in collaboration with science. By looking at more positive futures, it helps identify which building blocks of the world we currently don't understand enough of, so that we can pinpoint much better which vertical to be doing research on, where to be exploring much more specifically. You know, when people ask me what we do at PARC, you know, I often say that, you know, PARC's researchers do fantastic work finding deep answers about the way the world works. And then our group has to figure out what the question is. So now that we've defined design, let's look at research. Specifically, let's look at corporate research. So systematic, long-term corporate basic research. It's very expensive, if you think about it. And it only happens in a few very specialized circumstances. And let me tell you where I believe it happens. I believe it happens when the organization that is conducting the research has a monopoly, or it has a near monopoly, and wants to maintain that monopoly. When the Bell system, that was AT&T and Western Electric together, was granted a natural monopoly by the US government, they were essentially told they had to spend 1% of their revenue on research in the public interest. That is how Bell Labs was born. Bell Labs was not born because AT&T was feeling nice. Bell Labs was born because the government told them that if they're going to have a monopoly on telephony, they have to spend some of that on research. And in fact, you know, if they didn't want to be broken up, as they eventually were, they had to do that. When Xerox created PARC, it was the Google of its era. It had a near monopoly on creating, exchanging, and distributing information in office spaces, or in the office. It had an enormous patent portfolio. And when PARC was created, it wasn't like created as an intellectual playground. It was created with a very specific idea. It was created with a specific idea of maintaining that control and expanding it into the rest of the office from that one corner where the copier was. Peter McCulloch, who was the chairman of Xerox, called it the architecture of information because he meant the architecture of the whole space that work happened in. And he knew that computers had something to do with it. He just didn't know what. And all of those things about the Office of the Future fell out of that vision. And in fact, you know, if you think about it as a design relationship, there were some very, very clear design like qualities to that early PARC. There was a client who had a business model, Xerox. There were users, office workers, who had problems. There was a set of technologies that were being evolved that could be used to address those problems. They didn't know how, but they kind of knew. these things could be used. Look at the way that, and that's what kind of, I think, drove that early era. If you look at who has kind of advanced research today, you see it's companies in very similar situations. Google with X, near monopoly on ad banners. Facebook with Building 8 or whatever they're calling now. Near monopoly on social network ads. The research happens because these organizations have the space and the incentive to think in these big long-term plays. Other companies don't get that. But the problem is that this kind of monopoly-driven research is ending. When you have a globalized marketplace, you no longer have the kinds of regional monopolies that can fund open-ended research. X and Building 8 might be the last ones of their kind. Moreover, this maturing startup ecosystem has meant many large companies, even those that have these kinds of qualities, choose to innovate through acquisition rather than in-house R&D. They let the investors and founders take all the risks. And then when they're successful, then they buy them, right? In addition, the historical linear waterfall methods of doing research are breaking down. It is no longer incentivized in terms of the way the world works to work in a very narrow space and to kind of like dig and dig and dig and dig and dig in that, especially not on corporate research. That's what universities do. This is a mouthguard that PARC developed with UCSD. So what it does is it senses a wide variety of, it can sense a variety of different things in saliva and transmit them electronically. That's an antenna right there, the round thing. Transmit them electronically and then make sense of them through AI. So in order to do this kind of basic research, you need to have a knowledge of biology, chemistry, electronics, manufacturing, and AI in order to be able to go there. In order to understand how to put those things together, you need to have a target. Basic research now needs to be targeted much more tightly than previously. Researchers no longer have the luxury of assuming that somebody else is going to figure out how to apply their work to their sponsor's business. Now it's kind of everybody's job all the time. If you look at this, I grabbed this. I think I grabbed this from DARPA. If you look at the traditional development model, it's like boom, 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 boom. And that's like about a decade from when you get your first thing until something happens. Right? That's the traditional model. It looks exactly like a waterfall development model for those of you who know Agile. That is not actually how things work anymore in the world. Software, unfortunately, works over here. Software works like yesterday. Sorry, that came up. But software is did we do a thing? No, we got to pivot. Did we do a thing? No, we got to pivot. Did we get traction? No. Did we get the signal? No. So it works on this immediate churn. Meanwhile, if you look at corporate product management, they're looking at 12 to 18 month cycles. Okay, we'll release the new shopping cart improvements over here in May. They're looking at kind of this 2-year thing. So there's a huge gap between this 2-quarter world, between this and this. What's in that gap? I would argue that what's in that gap is design-led R&D. The design is the thing that allows you to close that gap, to tighten those practices, and to justify the kind of necessary sustained investment over the course of not necessarily 10 years, but 3 years, 5 years, to be able to bring things to market more quickly, but still have the fundamental transformative new technologies that you need. So what's our design method? It's probably, for those of you who do, it's probably not going to be that. We don't have we don't have alien technology here as much as we'd love to. But what we believe is that, like, just as science is defined by the Bacon's scientific method, rather than by any scientific specific discipline, like, regardless of where you are in those stripes, you're still basically using the scientific method. We believe that design is defined by its method, that there's a design method. And other people have talked about this, that is comparable to the scientific method. And so here's ours. So for us, it's kind of an iterative exploratory process, a kind of a search through multivariate possibility space to find the intersection of these three things, which, given what I was talking about, probably was kind of obvious. The opportunities for business, the needs of people out there, and the capabilities of technology. But you can't just like go to that triangle and go, oh, that's the thing. You have to iterate through a whole lot of different stuff in order to be able to get there. You have to look at your future cone, and you have to look at the possibility spaces. Those of you probably have seen this kind of future exercise. Like, there's a possible, there's a probable, there's a preferable. Here's all the stuff that's kind of possible. Here's all the stuff that's kind of probable. And there's like a subset of it that's preferable. So you look in the preferable future cone, and then you kind of iterate. And there's a whole lot of different things that might be in there. And you have to like keep going through them and then keep exploring them in this iterative way that explores, that connects between people, businesses, and technologies to find that triangle. So this is kind of our version of the double diamond diagram, for those of you who've seen. So we kind of do some stuff early on, and like think of the width of that as the number of ideas. So you get a whole bunch of ideas, then you kind of let's brainstorm and have post-its. And then you kind of drive down and converge on some smaller number of ideas, not a single pink dot, but some smaller number of ideas. Then you open that up again, and then you close it. Then you open it and close it. You open it and close it. And you do that repeatedly over and over again in order to be able to circle around all of the different multivariate uncertainties. What we do is and I'll tell you exactly, like, this is kind of my list when I was putting this thing together, like, what is it that we do? We simulate non-existing technologies. We do direct observation of people. We try to synthesize across disciplines. We try to bring as many people with different backgrounds as possible as we can. We try to create evocative artifacts that ask as many questions as they produce answers, with the expectation that we're not creating products, we're creating questions. We focus on business models, like how is it that people are now making money? What is the new way of making money? What's the, how is that trajectory made? Because ultimately we're a client-oriented consulting organization. We have to make money. We have to understand that. So we have to understand where that's moving as much as anything else. Where's society going? We call this the probe process, or we call one portion of it, where what we do is we throw away the notion that something is a prototype. We throw away the notion that when you make a piece of technology, that is on the trajectory to you making something that somebody can buy in Best Buy or whatever. That what we do is you create technology in order to ask questions about the world. You create, and it's not the same thing as kind of those of you who are familiar with critical design, where a lot of critical design stuff is to ask the user why they want the technology in the first place. But specifically what we do is we look at creating technologies or simulating technologies as a way of asking questions so that we can iterate more rapidly. So if you want, like, I'll also share these slides, but basically if you want, this is how it works right now. We do a little bit of what is otherwise called ethnographic observation. We observe the world. We create the hypotheses. That's the thing that a lot of organizations don't do. They don't try to apply that level of rigor where you're like, they're like, oh, I saw that person using a Post-it instead of having a tablet. I'm going to make an app for the tablet. Done, right? We essentially create a hypothesis. Well, why is that Post-it better than a tablet? What is the value that's going to bring? Then we create experiments to test those hypotheses. Then we actually, because so much technology these days has to be lived with, it's not just a UI that you click around. We make technologies that people live with for a period of time to try to understand their lived experience of the technology. Because ultimately, again, there's no clean way of defining that. Then we talk to them, rinse and repeat. So, we create a lot of different kinds of artifacts. Here's some artifacts. Some of them look like industrial design. Some of them look like kind of Internet of Things hacking with, I guess we don't have any pictures of things with wires hanging out. We do a lot of things like with wires that hang out. Some of them look like UI. Some of them look like rendering. Some of them look like a combination thereof. Some of them look like kind of patches that you might take with you, and we ask you, where would you put that patch if you had it? So one of the things that we don't do is we don't do the traditional linear user experience process that a lot of places do, where they work on this myth of unmet needs, that somehow if you just go out and talk to people enough, they will tell you exactly what they need, and then you can make a piece of technology that satisfies that, you're done, you're on to the next stage of the waterfall. We don't do that. We talk to a lot of people, but what we show them is we show them experiments that are designed to ask questions, help us ask questions of them, and to try to understand their behaviors and their attitudes in that way. All right, let me move on to a couple of case studies, and then we will, you guys can ask some questions. So the first one, we were approached by, tell me if I say anything I'm not supposed to. We're allowed to talk about this. So we've been working with Olay, with Procter & Gamble. We've been working with Olay for a while, for like 3 years, or more than that, 5 years, something like that. So they came to us with this question, and this was the really interesting thing. Like our clients sometimes come to us with this, and like there's a very specific pragmatic thing behind this, which is like they have a lot of SKUs. People don't know which skin product to choose. How do we get them to choose? But there's all these bigger questions around there. These are some of the bigger questions. So they came to us and they're like, okay, and since their target are women, so they always use the word she as the kind of this universal consumer. So we're using their language here. So she sees both the impact of intrinsic and extrinsic factors on her face, right? She is somebody who's out there. She has a life. Things happen. She has menstrual cycles and goes outside in the sun. Sometimes she doesn't drink as much water as she'd like. There are all of these things that affect your skin, But it's really unpredictable. Skin is really difficult and complex. There's a lot going on at the same time, and we don't want to become dermatologists just to be able to take care of ourselves every day. And that leads to this kind of lack of control. We can feel that in a lot of technologies, like people, or a lot of situations. Like a lot of what people want in their lives is they want more control, and a lot of what technology can do is it can help them find that control. Well, how can we bridge these things, right? And so, without an expensive consultation, how could she do these things? And so we were like, okay, this is actually a very interesting set of fairly well-bounded questions, but ones that require a lot of synthesis across different disciplines. So what we did is, so that photo that I showed earlier was actually from that research. So we started to talk to people. And so I believe in this one, James is actually just showing people pictures of their own selfies and asking them to talk about them. I think that they're just literally talking about selfies. And they're literally talking about what it is to take a selfie, and what is it that you see in your own selfie, and what is it that you see in the selfies of friends. And what does that mean to you? And how does that recording then help you understand yourself and your skin? That then leads to some very explicitly interesting questions that can be potentially answered through computer vision-based technologies. That is the arrow that points backwards. The future is that she wants to be able to pick things for herself better and wants to look and feel better and in more control. The how, the working backwards, is let's use some of our knowledge of computer vision and Procter & Gamble's knowledge of skin biology and machine learning in order to be able to create solutions that help her, and of course them, because they have a business model here, obviously, identify all of these different things, but in a way, I mean, this is not actually what the app looks like. It's also not our target audience, obviously. How can we make a better future for her using this? And in doing this, we then were able to ask all kinds of really interesting questions of the technology itself. We were able to push the machine learning. Now, there's like 4 or 5 deep learning models, I think, somebody correct me, that go into this. There's a bunch of like really hardcore computer vision that also has to be done on your phone. It's really like interesting technological challenge. Would not have existed if we weren't working backwards like this. And of course, we then end up with something that looks like a web design. It looks like an app design. And of course, we end up with something that looks like an app. And of course, that app then ends up being launched and has like millions of users, which is true. You can use this. But the point is that this is the desired future, or a representative of the desired future. This is the thing that solves people's problems and addresses their needs. And we try to figure out what that is and then work backwards to what is it that we have to research today. All right, next case study, and then we're going to wrap up. So here's a problem. Vaccines, it's very, very important. There's a lot of spoilage of them. There's a lot of waste in that space. And, you either get a bad vaccine when you get there, or you don't know if you got a bad vaccine. 40% of the time. It's a really significant problem. Okay, we can pretty clearly see a future that we want in this. A better future that we can envision in this. How do we get to that better future of where those vaccines are not going to be degraded? Well, one of the things we do is we start looking at how they're preserved. This is like one of the ways that we like, it's an iterative process. We're like, okay, how is it that you move that thing around? Like, where does it get hot? How does it get hot? How does it get, it's mostly about getting hot. Sometimes they get frozen, which is also bad, but mostly it's about them getting hot. So what are the different pieces? Let's look at the different pieces. Okay, let's look at the different pieces and try to unravel that and try to understand, okay, if we had a different kind of technology that allowed us to use AI to dynamically reroute things that are going to spoil before they spoil, and to identify things that are going to spoil before they spoil, and to be able to tell people when something is spoiled before they open it so they can reorder it, or tell them how much it's spoiled, that would actually be a better designed future solution. Well, so how do we cut across this very large universe of trucks and planes and boxes and different people who are handling it in different situations where that's happening? Here's an interesting thing that we found while we were doing research. Oh, right. Chemotherapy drugs have bad packaging sometimes. About $3 billion is wasted. What if we combine some of these ideas? And so we use personas so that you can see over here, like I grabbed this literally from our deck where we were talking about this. So we have a persona, which is like a proxy user named Samantha. So here are Samantha's concerns. There are some regulations. There's additional costs. We happen to know of some technologies, some sensor-based technologies, and some manufacturing-based technologies that might allow for a really cheap way to make primary and secondary packaging for vaccines that we could then couple with AI to be able to get all of those things that I was talking about earlier. Because otherwise, it's very hard. We don't have maybe necessarily access to all of the temperature data all the time. So we make some artifacts. We mock some stuff up, and we show it to people. We talk about it. We kind of look through, like, okay, if you had a thing like this, would that be a useful thing? If you had it, how would it fit into your workflow if you had it? And then we get feedback. We understand more about it. And then we iterate. and we iterate, and we kind of look at how we can change now, not just the vaccine process, but the shipping process itself from scratch. But using the existing infrastructure that's available. So maybe we can make some smart labels. And so we, over the course of 3 years, and let me, in the interest of time, I'm going to cut to the chase here. So over the course of 3 years, we went from this very big question, right, to the big reveal is actual smart packaging. So we went through smart packaging where there's, this is actually a prototype, because this actually, we're now out of the probe phase and we're now looking at prototypes, but it's still kind of a probe. Well, I probably shouldn't confuse things, but see, that's a printed smart label. It speaks Bluetooth, it speaks BLE. It can be made very inexpensively. It senses temperature for a certain kind of thing. That is a kind of prototype. You can actually kind of see the antenna through it. It's a sensor label. You can stick that onto the side of secondary packaging. You can transfer that around the world. We're actively working to develop this. But the point I want to make about this, and we're very, very proud of this work because it does go across, like, how do you make a sensor? You need to know chemistry. How do you then print it really inexpensively? You need to know both manufacturing and how printed electronics works, which is a completely esoteric field that we just happen to be expert in. How do you then make sense of that once you have that data? How do you gather the data? How, there's all of these different questions. But the point I want to make is that in order to be able to focus on answering those questions, on breaking new ground in the development, the technology development of each aspect of that, you need to have this future vision of what you're trying to do, and you need to iteratively get there so you can prioritize. Thus driving simultaneously, not necessarily a product, but a set of basic technological research. And that is how we believe that design and research can work very closely together to create completely new, disruptive, transformative technologies. And that's what we're going to be working on kind of going forward. So thank you very much. I forgot to put my name there, but I will in a minute. So thanks. Now, please ask questions. Here.
Thanks, Mike.
I'll put my name there now.
All right, so let's open the floor to some questions. Who has a question for Mike? All right, Anna, could you get that gentleman right there? We have microphones for everyone.
Thanks, Mike. Great talk. How many people on your team, and when you are prototyping and researching devices and things with users, how do you work with different cultures, people out of the United States and so forth?
Both excellent questions. I think currently we're about a dozen people on the team. So we have about 12 people. A couple of those people are full-time in Japan. The rest of them are basically here in about 400 feet that way. And how we work with various cultures is, for certain things, we go out there. We send our own ethnographers out there. But for a lot of things, we work with people who have local expertise, who can be translators, either literally, linguistically, or also culturally. For example, when we were looking at the process of giving recommendations on various Olay products in China, that was one of our initial markets. What we did is we were like, okay, so the hypothesis is that if you get kind of real-time advice about what you should and shouldn't get as you're shopping in a department store, that would be useful to you. And we're like, okay, that's a reasonable hypothesis. How do we test that in the lightest way possible? Well, we hired a Beijing-based ethnographer and gave him essentially both the script, but also a set of guidelines. And he obviously kind of helped us frame those questions. And then literally he walked along next to people that we had recruited in Shanghai as they went shopping, and he'd go like, yeah, have you thought about this? And he like knew like what to say and how to say it, but he literally gave them advice. And then later asked them, how did it feel to have advice being given to you about these things in this situation? And then he took all of that and he summarized it for us and gave it to us and then kind of explained, you know, how we should interpret their statements based on what he knows about that context. So that's, I think, a good example of how we, that's what we try to do. All right, more questions.
Another question?
Up
There you go.
front.
So I'll get.
First of all, thank you. But coming from product management, it seems that in order for me, when I go into a new product, I have to have lots and lots of money in order to approach you, because the problem and the flaw that you described, one or the other, I would do today with my UX designer, with my knowledge of what the customers are looking into, what is the problem that I want to save. The triangle that presented in the beginning talked about, you know, business, I mean a for-profit company.
Sure.
So the assumption that I would come to you if I really have less stress on time to market and more money, is that a fair assumption?
I think that's a very fair assumption. As I was saying, like if you're a PM, you are generally making version like 6.82 of whatever it is that you're doing. We only make version 0.1 of anything. If you want a completely new transformative product, service, and you are looking 3 to 5 years out for that product or service to transform the market in your favor, that's what we work on. If you are evolving the thing that you have today, a reasonable, straightforward, well-done user experience design process is going to get you that.
Or the alternative would be if I'm a serial entrepreneur, I already, you know, got a couple of exits, got through spare millions I'm gonna spare. All I need is the idea and come to you. I don't need engineering team, I don't need design, I just need to come to you, negotiate what will be deliverable, and I'm done.
In a sense, because we'll then ask you like,
I know what I want.
how much do you know about your idea? Okay, do people really do people really want, you know, whatever glow in the dark shoe soles? You know, let's explore that concept. But yes, that's exactly how we work with certain organizations. So yeah.
Other questions?
Thank you for the lecture. Have you, in your cooperation with your researchers here, have you encountered situations where, you know, the problem you need solved does not always align with the research interest of the, you know, the targeted research team? You know, then if you have encountered such situation, how do you find a common ground, you know, and get things moving?
That's an organizational cultural question. PARC's organizational culture is changing. Researchers don't really get, like, they also follow the money. And if there's money behind answering a question, they are interested in pursuing that. If their research so we have several different kinds of ways that we fund our research. We have US government grants that fund essentially more open-ended, longer-term research. You know, that's typically measured in the you know, couple of years range in terms of the impact of that, or not the impact, the size of that project. And then we have a lot of commercial clients. And the way that we typically work is that that research is more focused, like what I described, where some amount of the core knowledge will have either been brought in from people's university background or their PhD work. Some amount of it comes from their research that they might have done on a government project as part of what their research lab is doing. And some of it is now being framed by the work that we're doing that's looking at that medium space, like not the 10-year space, but like the 3 to 5 year space. And that's where we bring them, that's what we bring them. So in a sense, our researchers, we're not like a university where they pursue, you know, we don't have tenure. You know, they don't just like go off with graduate students and do their own thing for 5 years and nobody knows what it is. Like that's not how our research culture works. It's much more targeted at all stages, but there are different, essentially, horizons that are created by different funding models. And sometimes there might be like, I don't think this happens that often, but there might be like a very specific request that says, from one of these larger companies, like, we need this specific technology in 6 months that's based on some research that you had done. Can you make that? And then the researchers might in fact drop everything that they're doing and just make that, because that is really good money. And so that will then, and then that technology might then be applicable to something else. So I think does that answer your question?
Yes. So do you balance between how much you put into commercial products and therefore probably trade secrets, and how much that you publish as a research institution?
So I think that is also a shifting cultural thing. So historically we have published, but I'm not sure, somebody can answer. To some extent, in order to incentivize researchers, you often have to create situations where they can publish, but that is not the only way that people are rewarded here. And so therefore, the publication is not necessarily the primary means the primary incentive for people. So therefore, they following these interesting projects might actually be more interesting.
Thank you.
Yeah.
I was just curious to hear your thoughts on if you have any like concrete strategies for kind of balancing between like keeping an open mind or like broadly approaching a question or a problem space, and then also at the same time coming to like a deep understanding of particular solutions or spots in the solution space.
I mean, that's always a balance. How much do you kind of bring in, like, so as I talked about, we have this divergence convergence process, and we explicitly try to frame the times when we're going to be diverging, so that okay, now we're going to bring in some other things, but it's from a smaller space from the last convergence. So now we're going to bring that in, but we're not going to bring it in until we're exhausted. We're going to bring it in for like a little while, and then we have to converge again, because ultimately, you kind of have to keep the cadence, and that I think really helps us kind of frame what it is that we're doing, and get us like kind of unexpected perspectives, while at the same time eventually getting to something that our clients consider to be valuable. So.
All right, well, I think we're going to move into the networking part of the session. So thank you, Mike, very much for...
Thank you.
So there's some food and refreshments out in the back. Mike's going to be here a little bit, so
Yeah.
please feel free to come up, ask him some further questions, and mingle for the next
Well, thank you.
30 minutes.
And a chunk of my team is here. Can the people that are on that are in ISG hold your hands up so people can ask you questions?
ISG in the house.
Yeah.
There you go.
So there's a handful. You can ask them how we do what we do if we do it.